morning, students. Today we are starting the topic turning moment diagrams in the unit of precision and gyroscopic couple. After that, after precision and gyroscopic couple, we are going to enter into a topic turning moment diagram. In this, the turning moment diagram is nothing but the crank effort diagram. That means in an engine, we know the suction, compression, exhaust. Meanwhile, we are having a power stroke. So, the turning moment diagram is also known as crank effort diagram, which means where the crank effort is or the useful energy is created in an engine, that is called power stroke. So the, how the movement of the crank or the crank changes the power. So the diagram of turning moment will give the crank effort, how the crank will be creating the energy and how the crank movement, with respect to crank movement, the crank movement we will discuss along a x-axis and how much of energy due to the crank that will be entered in the vertical axis. So that the crank movement is in the rotation. That is, the crank movement is in the rotation of angle. So the crank, how much of rotation of the crank angle means we will represent it in radians. That is pi, 2 pi, 3 pi, 4 pi. So 180 into 4, 320. So like that, the crank angle based on the crank moment, how the diagram will be comes to the picture. So, the turning moment diagram is a graphical representation of turning moment or crank effort for the various positions of the crank. So it is a fully a graphical representation in that the crank, how much of crank is or how much of crank effort for the delivering of the energy. So the position of various positions of crank with respect to that how much of energy was delivered. So this is plotted in a graph, that is a Cartesian coordinates, in which the turning moment is taken as the ordinate and crank. So in this we are in a continuity. So what is the purpose of the turning moment diagram or TMD, that is, or crank effort diagram, both are same. The turning moment diagram is a graphical representation of turning moment or torque along a y-axis, and the crank angle is on the x-axis according to the positions of crank. Previously, just now I told that the crank angle is taken into the account of radians. According to that, what is the moment created? That is, these two are related, and these are representing in the graphical representation. What is the uses of turning moment diagram? The area under the turning moment diagram will give the work done per cycle. So, how much of work is done per the cycle of rotation of a crank? The work done per cycle when divided by the crank angle per cycle will give the mean torque. So we have to find out the torque or torque delivered or torque required. So how to calculate means we, after getting the area of a graph which is coming from the TMD divided by, that is called the work done, divided by what is the crank angle. We have make it out is this ratio will use the mean torque, that is Tm. Next, the uses of T in the continuity. The mean torque is multiples by the angular velocities of the crank that gives the power consumed by the machine or developed by an engine. So how much of mean torque will give uh, the entire power consumption or angular velocity of the crank are related to machine or developed by the engine. So how much of energy is required or how much of power is required to run the machine or how much of energy is delivered or developed by the engine. These are the countries. So here, how much of energy is developed is nothing but the how much of power consumed by the machine. Both are almostly same with a nominal loss of energy. Yeah. The area of the TMD above the mean torque top line will represent the excess energy that may be stored by the flywheel, which helps to design the dimensions and mass of the flywheel. So, after getting these TM, that is mean torque line, after getting these, we will make a line on the graph. Above these mean team line, we will represent that it is an excess energy, and this excess energy will be stored in the flywheel. So as to maintain the engine in a smoother manner. So according to that, we have to design or the shape of a flywheel is to be in that manner. So what is the purpose of a flywheel means? It will just like a what we call reservoir. Okay, reservoir. The flywheel is looks like a reservoir. That means whenever the energy is more than the requirement. So whenever the energy is available more than the requirement means it will store the excess energy than the requirement. And then, and what about this limited energy when the machine supplies or developed by the engine is very less. I mean, the developed energy is very less than the requirement. So the what we call there is a extra supply of the energy is to be required to run the machine in a smoother manner. Then the flywheel will helps the machine to run the entire system in a smoother manner. The what the excess energy in the previous it has stored that will be helps here to run the machine in a smoother manner. Right. Next, flywheel. Just now we thought that the flywheel is a device used to store energy and available in excess and release the same when there is a short. And these flywheels are